Hi viewers, here we will discuss about the introduction of Bayes theorem. Bayes theorem is used to calculate the probability of an event with random knowledge, which is used to calculate the conditional probability and uh, using and relating to the marginal probability and conditional probability. So here the features of Bayes theorem is each observed data point from the given data set can incrementally decrease or increase the estimated probability that a hypothesis is correct. That means we will guess the solution, the initial solution. That initial solution will be optimized either by incrementing or decrementing the value using parameter optimization. The prior knowledge can be combined with the known data. Observed data means known data point to determine the final probability of the given hypothesis. The Bayesian methods can accommodate hypotheses that make probability predictions. The new training data points can be classified by combining the predictions of multiple hypotheses weighted by their probabilities. So these are all the features of Bayes theorem. Uh, for example, there is two independent events tossing the two coins. So two coins are independent of each other. The outcome of each coin is independent of each other. The dependent events example, consider the five balls in the basket. So here this is the basket. Assume this is the basket which is having the five balls. Here two green color balls are there and three blue color balls are there. So here the probability A is considering the green ball which is taking out from the basket. So probability of A is taking one of the green ball out of this five total number of balls. So here we are having the two green color balls. So from this two we can take any one. So which is taking 2 divided by 5. So taking the green ball out of the basket, total 5 balls is 2 divided by 5. So now the event A is already happened. Now we are going to calculate the event B from the A. From the A. So now after probability of A, the basket is having 4 balls. 4 balls. So again we are going to taking one more green ball. One more green ball from the basket. This event is dependent on the first event. So we are going to take one more green ball. Here total number of balls are 4, the green ball is 1. So probability of B given A is 1 by 4. So this event is depending on the previous event. So this is called dependent events. Then next one is the joint probability is defined as the probability of two simultaneous events, two or more simultaneous events. So here we will consider A and B are two events which are from two dependent random variables. Random variables are here considered as x and y, denoted as probability of A intersection B or probability of A comma B. So A is one event, B is another event. The both are from the dependent variables x and y. The joint probability can be calculated by using the conditional probability, right? The conditional probability is given already. Probability of A given B can be used. Probability of A intersection B equal to probability of A given B multiplied with probability of B. The probability of B intersection A can be calculated by using probability of B given A. This is the conditional probability multiplied with probability of A. So here when you are substituting the values from this probability of B intersection A, we are getting the 1 by 10. So the joint probability is the symmetrical. So we can take the probability of A intersection B equivalent to the probability of B intersection A. The conditional probability is defined as one event given the another event. This one event is already occurred. That already occurred event given the occurrence of another new event. So here for example A and B are the events which are from two dependent random variables x and y. We can write this as probability of A given B. So it can be calculated using the joint probability. So probability of A given B given defined as probability of A intersection B divided by probability of B, probability of B. So here this is joint probability. So this one is conditional probability, but the conditional probability is not symmetrical. So this is both are different. The joint distribution here, example given. So for m number of variables, we are making the joint distribution by using the truth table, which is listing all the combinations. For each combination of values, what is the probability, so here when you are calculating the joint distribution, the total probability sum should be a 1. So here we are having three combinations, three variables combinations. We are writing the values. So for each data point we are having the probability. So when you are calculating, sum of this probability should be 1. Sum of the probability should be 1. So which is given here, right? The probability of event variable A, probability of variable B, probability of variable C. So the sum should be 1 in joint distribution. Here the base theorem is used to calculate the conditional probability. Earlier we used joint probability to calculate the here we used the joint probability to calculate the conditional probability. So without using the joint probability, we can use we can calculate the conditional probability. We can calculate the conditional probability by using the Bayes theorem. Okay, so here the Bayes theorem, probability of A given B equivalent to probability of B given A multiplied with probability of A divided by probability of B. In reverse, we can say probability of B given A, probability of A given B multiplied with probability of B divided by probability of A. So here the probability of A given B. So in this equation, okay, in this first equation, the probability of A given B is called posterior probability. Probability of A given B is called posterior probability, and the numerator first one is called maximum likelihood. Probability of B given A is maximum likelihood, and the probability of A is called prior probability. Probability of A is called prior probability, and probability of B is called marginal probability. So here we are having four different terminologies, right? In the numerator we are having maximum likelihood, and this is prior probability divided by marginal probability. So this can be derived by using the joint probability also. You look at that. So this is using the joint probability. So without using the joint probability, we can derive by substituting these values, probability of A intersection B and probability of B intersection A. We are substituting these values. Then finally you will get probability of A given B equal to probability of B given A multiplied with probability of A divided by probability of B. So here we are not having the joint probability. So without using the joint probability, by using the Bayes theorem, we can calculate the conditional probability. So there is the purpose of Bayes theorem. Another uh, kind of rules here, probability of A given B, uh, probability of B given A multiplied with probability of A divided by probability of B. Here, which is calculated by using with respect to the variable x. X is the random variable. Probability of event A given probability of B, comma, with respect to random variable x can be denoted by probability of event B given event A with respect to variable x multiplied with the probability of A with respect to random variable x divided by probability of B with respect to random variable x. So it is also denoting the Bayes theorem. And another one way here, probability of B given A multiplied with probability of A divided by, here the A is already occurred, right? A is already occurred plus A is not occurred. A is not occurred. The what is the probability of B? So using this format also we can apply the Bayes theorem to calculate conditional probability. Thanks for watching.